2-8 is literal equations in dimensional analysis. Sounds really complicated, but we'll make it less complicated because we're not going to do dimensional analysis, so you guys will like that. Literal equations just means an equation that has a couple of variables in it and that we use like for formulas and stuff. So what we're going to do this section is we're going to solve equations with a couple of variables, and we are going to look at how to use a formula to solve a real-world problem. Not too complicated. I've sort of shortened this lesson. I think you guys have plenty of material you have to get good at for this test on Friday, so we will just leave it at that. Well, that's an interesting slide, don't you think, guys? All right, let's try the next slide. All right, there we go. Some equations have more than one variable, and sometimes you need to solve an equation for just one of those variables, and that's what we're going to practice doing today. So for instance, excuse me, I have 4m minus 3n equals 8. All right, and it says I have to solve for m. So m is the variable that I need to solve for, and that means in the end, m is going to equal something else over here. I don't know what it's going to be. We're going to find that out. But we're going to end up with m alone on one side of the equal sign. So here we go. Let's add 3n to both sides. And we get 4m equals 3n plus 8. I always like to put my variables before my whole numbers. And I still need to get the m alone, right? Here's my m still hanging out here. Okay, so I'm going to divide by 4 and divide this entire thing by 4, okay? The whole equation, just like we had to multiply the whole equation by 4, now we have to divide the whole equation by 4. So then we get m equals 3n over 4 plus 8 over 4. So that's the same as 3/4 n plus 2. And that's the solution to this problem. Shall we try another one? Would that make you guys feel better? Let me go back to this blank page then. Let me find another problem for us to try. Let's try, well, I'll do the first one of your guided practice for you. 15 equals 3n plus 6p. 3n plus 6p, and we have to solve for n. So we're solving for n. Okay, well, and here's our n way over here. Oops, sorry. And here, bad miss. No, that's not our. Here's our n. I'm struggling. It must be Friday afternoon, right, guys? Okay. So we're solving for n. So let's subtract 6p from both sides. And we get 3n equals negative 6p plus 15. Now I want to get the n by itself, so I have to divide both sides, the whole thing, by 3. Cancels out. N equals negative 6 over 3p plus 15 over 3. Negative 6 over 3p is a negative 2p plus 5 equals n. All right, so then you have another 3 practice problems to do. We just did 1A. You guys to go ahead and do 1B, 1C, and 1D. Looks like you're going to have to distribute a little bit. Maybe not. Well, anyway, good luck with that. Yeah, you will have to distribute on a couple. So I'll see you in a second. Okay, sometimes we need to solve equations for a variable, and the variable is on both sides of the equation. When this happens, you get all the terms with one variable onto one side of the equation first. And this also says, it is then helpful to use the distributive property to isolate the variable for which you are solving. So let's look at an example of how that might work. Okay. Here's what's our study tip tell us? It's when an equation has more than one variable, it can be helpful to highlight the variable. Well, we've been doing that. So let's try this problem. 3x minus 2y equals xz plus 5, and we're solving for x. Okay, so what shall we do first? Let's get our 2y. We're going to isolate our x, and we'll probably isolate our x on this left side over here. Okay, so let's add 2y to both sides, right? And we get 3x equals xz plus 5 plus 2y. All right, now let's subtract our xz and get it over so we have all our x's at least on one side. And then we have 3x minus x, minus xz equals 5 plus 2y. Now you'll notice we're going to do sort of the opposite of distributive property. We're going to undistribute. Notice that both of our terms have an x in them. Okay? So if I take the x out, both the x's out, what do I have left? 3 minus z. Now think about that a second. Now let's distribute. If I go x times 3, I get 3x. If I go x times z, I get xz. So do you see how we could pull the x out, put in our parentheses, and make it look like a distributive property? And then 5 plus 2y. Remember, we're still trying to get who? We're trying to get x. This is the guy we want by himself, right? Okay. So it looks to me like I need to divide by parentheses 3 minus z on both sides. Divide by 3 minus z. Okay? That cancels these guys out, and I get x by itself. Extend my page. X equals 5 plus 2y over 3 minus z. And that is about all you can do with that. So there it is simplified. We've isolated x. You might want to watch that problem one more time. This is a very short lesson, but it's a little bit, got to think about it. The tricky thing here is if you have, when we were right here in this area. So let me give you another example. For example, if I had 5y plus xy, right? I could pull my y's out, and it would be the same as 5 plus x. You see that? I can pull this y and this y out and leave what's left in parentheses. What if I had 2k 2k plus 10 No. Let's not do that to you. I won't make it that complicated. What if we have one more time, like say we have um, ky plus 2k. All right? Let's take our k's out, and what do we have left? We have a y left, and we have a 2 left. All right? All right. Here are your practice problems. Do these two. Okay, and finally, let's apply this solving for a variable in a formula, in a real world problem. So we know we have the information over here about the yo-yo. The largest yo-yo in the world is 32.7 feet in circumference. It was launched by a crane from a height of 189 feet. So the formula for the circumference of a circle is c equals 2 pi r, where c is the circumference and r is the radius. So what are we supposed to find out? We're going to find the radius of the yo-yo. Okay? So first we're going to solve our formula for r. So we have c equals 2 pi r. We want to solve the formula for r because that's what we need to know. So what are we going to do? We're going to divide both sides by 2 pi. Divide by 2 pi. And we find out that r equals c over 2 pi. And then we can find the radius of the yo-yo because we know so we're going to use c equals 2 pi, c over 2 pi equals r. We know the circumference is 32.7 feet and 2 pi, and we can find r. All right? So you'd punch that into your calculator, 32.7 divided by 2 pi, and you would get that the radius is approximately 5.2, where are we? What are we? Feet. And we use our approximately sign, and that's approximately what the radius equals. So there's a way you would apply that where you isolate an equation for a certain variable. That is it. That's a nice short lesson. Yep, we'll talk about it on Tuesday or Wednesday, whenever your class meets. And that'll be our last lesson for this chapter. We'll review on Wednesday or Thursday, depending on your class, and then we will have our Chapter 2 test on Friday. Thanks, guys.